Then I will continue and go a bit more into the direction of I/O now. The rough software stack, when you include openPMD as the I/O method in your application, is going to look somewhat like this. So no matter if you write a writer or a reader, typically a writer will use the C++ API, the reader the Python API. That's more or less the typical workflow that has shown to exist. The openPMD API itself talks to its backends HDF5, ADIOS, JSON, and TOML. And those again, in their respective backends, data transports and storages use different technologies like POSIX, MPI-IO, parallel file systems, write to a stream via InfiniBand, Slingshot, TCP/IP, and so on. And in order to, so on the left-hand side, you have the scientific data description. On the right-hand side, the stuff that tries to be performant on file systems, and not only file systems, but networks and general data transports. The way that this works is you ideally write one code that specifies your interaction with the data. And then down below, you see that the configuration for which backend do I use and which options do I use for that backend is then given in a configuration file, which you can either specify inline or load from a file, either in JSON or in TOML. So for example, here the ADIOS config specifies that the backend should be ADIOS, and we add an operator for compression via BLOSC, or for HDF5, we add a virtual file driver for subfiling, or we load something maybe from file, which is, for example, useful for SST, which is the Sustainable Staging Transport of ADIOS, so the streaming engine, where you might want to load something from a file because the configuration is read by both the writer and the reader. So let's go back to the code and tinker around with the runtime configuration again. By the way, since I saw you taking a picture, these slides are also online and already downloaded if you cloned the Alpaca workshop slides. There are some additional slides that are probably not in your download yet because I added some last minute. So I will add those again at the end of the workshop or at the day. But apart from that, so let's go into JSON and TOML configuration. You see that in this folder I have added a configuration in JSON and the same thing in TOML. So, okay, apparently I don't have a TOML plugin installed, so I don't have code highlighting. The nice thing about TOML is you can also add comments, unlike JSON. So this configuration shows that we are using the ADIOS backend, that we are now going to use group-based encoding, which is going to write data not into multiple files, but into distinct groups within one file. We use the BP5 engine of ADIOS, which we have been using so far anyway. There are some backend specific parameters which we pass through onto ADIOS. This is going to be relevant for the streaming bit in later on. And this is computing statistics for datasets that are being written. And this down here is BLOSC configuration for compression via BLOSC. So let's go back to the code. Binary pack. It's an engine by Alios. So also we didn't explicitly specify that we are writing to Alios so far. Yeah. So here we have backend Alios in the file. If you don't specify this, it will be automatically determined from the file name extension that you specify. So we specified so far BP5, so openPMD said, okay, it's BP5, we are going to activate the Alios backend. If you exchange that to .h5, it will write, for example, an HTML5 file. Let's hope my voice will make it. So, yeah, exactly. The code now contains some instructions. I will give you maybe 5 minutes for reading through the instruction. It's really, it is a lot, but it's only changing the constructor call in order to prepare for first interacting with the runtime configuration, and then later on to prepare for the streaming example. All right, so there are basically 3 things we need to change. First of all, we are not going to write to separate files anymore, so we can remove this part. Then we take the configuration for the backend from the JSON or TOML file, so we can remove that one too, or replace it with a pattern that will be expanded. And then we specify the path to the configuration file. I will continue using JSON. You can use either as you wish. I just use JSON now because the editor actually supports the syntax highlighting. I normally prefer TOML because it's much easier to read, but not if it looks like this. So this is basically the only thing that is the only line that we are changing during this part of the programming session. In the code directly, the rest will be in the JSON config. Basically, what I could also do is just write a JSON string in here directly. This would exactly, yeah. So by default, it would be interpreted as something passed in line. And this is a syntax that we have kind of taken from command line tooling such as, don't remember the name, something, widget, is it widget? Something. At least there are some command line toolings which use also the @ symbol for referring to files, so this is what we picked. And this is then going to be interpreted as a path. So I will switch to the new folder, run the CMake configuration again. And if you use the folders that are prepared in the examples, I have already symlinked the configuration into there, so you have it and the example will find it. So you see here they are. Let's build this. Run it again and look into the resulting folder. There's only one BP5 file in there right now compared to the 50,000 that we've seen before. But if we look into it, we see that it has the heat mesh 400 times. So all the data is now in one single file. Maybe one little word of advice, the group-based encoding I'm currently using for demonstration purposes in ADOS. For performance reasons, don't use this in ADOS. In ADOS, either use variable-based encoding, which is specific for ADOS, or file-based encoding. Group-based encoding works best, if at all, in HDF5 files, and generally for when you have a low to mediocre amount of iterations. So it's nice to have everything in one file, but there are also downsides to it. This one. Yeah. If I print the options, then I will get the attributes also 1,000 times. That's what the variable-based encoding does better, which we will see in a minute. But for now, let's stick with this one. So maybe as a next step, what would I need to change if I wanted to write HDF5 output? If I change the type in here, that's the type of the ADOS engine. We only need to change the backend, because you can basically specify ADOS configuration and HT5 configuration side by side, and the backend will then pick the configuration that it wants to have and will ignore the other. So we only need to change this one. No, because this is inside the ADOS branch, so HDF5 will ignore it. ADOS has many different engines, and we are going to change the engine type in a minute for switching from BP5 to SST for streaming. But now we don't use ADOS at all, we use HDF5. So for HDF5, I don't have explicit configuration here. If we wanted to do that, we would add a new line with HDF5 here and then some empty options. But we will see HDF5 configuration tomorrow when we use the virtual file driver for subfiling. But this is one key point that we decided on for the design of these configuration files, that you can have configurations side by side for multiple backends at the same time, and the backend that you actually choose will then pick the configuration that is dedicated for it. So if we run this again, you can look at the output, and there's additionally now an H5 output that we can use native HDF5 tooling. For example, H5ls minus recursive to read that one. And then we get that output. All that without recompiling, just changing a little line in a configuration file, and suddenly it's not ADIOS but HDF5. This one. Minus R is for recursive, otherwise it's going to show you the root group, and that's not really interesting, so yeah. So I will give you some time. The remainder of today will be to use what we built so far in order to go over to streaming I/O. And for streaming I/O, I will use an additional visualization. And as I've already threatened you, we will switch over to Jupyter for doing that. So this is now the point where we can close the editor. Now I don't know how much resources we have in the allocation. I assume it might become necessary to actually cancel the jobs if you have a running Jupyter Notebook job in here. I will leave mine open in case I need to show something again that I still have it. But otherwise, we're going to switch over to Jupyter. In the lumi.csc.fi website, pick our reservation here. We are going to use at least 2 CPU cores, at least 4 GB of memory. We can keep the 1 GPU. We will not work longer than 4 hours today, so we can also keep that. And now the most important bit is, down here you have a toggle between basic and advanced. We are an advanced workshop, so we take the advanced toggle, because this allows us to input here the path to the environment, that it will be automatically loaded by the Jupyter Notebook, and that we have all the software packages that we need installed in the Jupyter environment. I will post the path into the Zoom chat if I can find the window. Do I find the window? Come on. Chat. There it is. So this is what you need to put in there. And then submit or launch. This will take a small amount of time to launch now. So Yeah, I will wait for some minutes in order for everyone to actually have this Jupyter notebook launched, and then we can continue with that. So at some point, this card will show you a button for connecting to Jupyter. Don't spoiler. So do you have the Jupyter notebook running? Still queuing? Okay. Should I go ahead?
Sure.
Okay. So the first part, or what we are going to do for now, is really just trying to set you up and not even program or code anything. So we open again. Here on the left-hand side, you can navigate through to the 11 visualization folder. And there's additionally now a Python script in there. You don't need to code anything in there. You just use it as it is. And you can import this Python script as a package, and then you have a function called main that you can specify a file name, and it will visualize data from that file. So let's create a new Jupyter notebook by clicking the funny button and picking a new Python 3 notebook. Import that, import right, then we can specify the file path to some of the data that we just wrote. Please do not use the group-based ADIOS output that we just produced, because as it's we are currently in the process of deprecating it, and there are some features that we don't support any longer for group-based encoding, so you will get an error if you use that in this specific script. So use either the HDF5 file written just now or one of the file-based outputs written earlier. So file path we specify here as the HDF5 thing. Okay. And then try to run it. And of course it doesn't work. So I've given a wrong file name. Ah, okay. Fingers crossed. Yeah. So here we are watching the heat equation.
Here it's displaying each frame in 10 frames.
Yeah, exactly. So it's just going through the iterations from the first one to the last and displaying them. We are tomorrow going to use, as I already announced, some actual software packages that visualize openPMD automatically. This is now something that I've handwritten for this particular use case, so that you basically have seen both. Is it working? Okay.
I see.